Hello, this is Shaun Thomas, and today I'm going to go over my EGR425 Project 4. So first I'm going to go over my M5 um, demo, and as you can see, I have my user name, proximity, ambient light, white light, temperature, humidity, and the accelerometer data, as well as the current time zone timestamp. So if I put my hand right here and cover it, you'll see the proximity go up and the ambient and white light go down. And as I remove my hand, the proximity should go down and the light should go up. And as you can see, the temperature is slightly changed as well. Um, so this is updating data into my Firestore database. As you can see, this one just got recently added. And it displays the capture time, and then the humidity, temperature, proximity data, and these are light data as well. I'm not sure which one's which, but my M5's accelerometer is broken, so that's why the accelerometer data is all empty. Um, so this is getting updated to Firestore in real time. As you can see underneath my username, which is the same username on M5. And then if I go ahead and click my B button, it's a little hard to see on the M5, but this is currently green, this is currently green, and this is currently green. And that's a little better. Essentially, the top three buttons all have my username because it's hard coded for one user. The middle row has 5 seconds, 30 seconds, and 120 seconds. And the bottom row has temperature, humidity, and I think that's accelerometer data. But anyways, if I choose humidity, I could click that, and I could choose in the last 120 seconds. And then I could choose my name, but I guess they're all my name. I could choose that, my name, if I wanted to. And then if I click the C button, this will fetch data from my backend. And this now displays the data type which I just selected, which is the humidity. It shows the average of the last of all the data types of all the data that was sent in the last 2 minutes or 120 seconds, which is 63.02. It shows 58 points and the rating per second, which is 0.4874, and elapsed time, which is just under 120 seconds. And that correlates to all of this data. For the data type, which is our humidity, average data point, which is again 63.02. The range of actual data and duration, which is 58. Price that's 0.4874. And then the number of data points is 58, which is the amount that was sent in 120 seconds. Mine updates sent every 2 seconds instead of 5. And then the rate was 0.4874. And the elapsed time was 120 seconds, which is this part. So that's all the M5 functionality I want to demo. Now I'm going to walk through the M5 code. So essentially, I have this setup for my BCNL and SHT40. I have the struct for my data I want to send, and then a struct for my second cloud run function, and then a struct for my circle button, screen state, and then current screen state. These are just hard-coded values for the 3 rows of buttons that I showed. My user ID, time duration, and data type. So essentially what happens here is I first set up by setting up my M5, setting up the NVCLL 4040 and SHT40, I believe, and then connect to Wi-Fi. Here I loop, and if the A button is pressed, we go back to the first screen. If B button is pressed, we go to the second screen where we configure what we're looking for in the second Cloud Run function. If the C button is pressed, we will we'll send a request to the second Cloud Run function and hope to get a response from them with data that will be displayed in a different function. If we have the main screen, it just pretty much displays all of the data that's being pushed to the first Cloud Run function. If it's not, then we set up the screen that will allow us to select what data we want to send. Otherwise, we are displaying the screen that shows what we have picked in the last X amount of time. Here is the first Cloud Run function get call. I believe it's pretty much similar to the original code. Here is a function that I believe pretty much just makes a JSON of the current data that the M5 is collecting. Here's another HTTP get function that send with headers. And then here's one that writes data to a file. Again, I believe these might be from the original code. I believe it's also from the original code. And here we make a post function, sending a file. Just look for my functions. Here we display the sensor data on the original screen. Here we make a call to our second GCF Cloud Run function. Essentially, what happens here is we look for the data by sending in parameters, the query parameters, user ID, the time duration we want, and the data type that was selected by second screen. And then we call the HTTP request, and then we deserialize it into JSON, and then we unpack it and we return what we need. And then here's just a function that displays the data we got from the second Cloud Run function. Here's a draw circle button that, again, just draws circles from the hard-coded values so that you can easily press them. This function draws string 2. It draws all the circles that we need. Here determines if there's that given a circle and given the X and Y, if it falls within that circle. Here is where we determine here's how we determine what values and what data is sent over on the second screen by clicking, so that when a user selects a button, that data is saved so that can get sent in the second Google Cloud Run function on the third screen. So that's all the M5 code. Now I'm going to walk through some of my Google Cloud Run function code. I believe this is the original code that takes in the M5 request and uploads it to the Firestore DB. So pretty much what we have here is we destructure the request. I believe, let's see. Yes, right here. So we get that from the data that's sent here. We structure that into the different values. And then we set that into these variables. And then we upload that into the database over here, I believe. Yeah. Yeah, this is the Google storage bucket, so this is the database. All right, and then here's the second Cloud Run function. And essentially what this does is it will take the latest values uh, given the input from the parameters. So we have the user ID input defaults to my username. Is provided in the time direction defaults to 30, and then the data type defaults to temperature. Again, this is all sent in from the query parameters. And then here we essentially will look for all the data that's within the time duration. And then that will get averaged in all the values. And then we send all this data pretty much. We send all that data so that the third string can see that and display all that. So with all the functionality and code I wanted to demo for EGR425 project 4, I believe.